Hey, integrated science friends. Today's lesson, we are going to talk about why the Earth has seasons. Why is the winter cold and why is the summer warm, basically? And is it the same everywhere on Earth? Why, or if it's not the same, why is it different? So we're going to watch a video by my friend, Mr. Bill Nye, and he's going to explain to us how the seasons work.
The seasons. It gets cold in the winter. Flowers bloom in the spring. We get lots of sun in the summer. And leaves fall in the fall. See, the Earth's seasons affect every living thing on Earth. That's right. Seasons affect the way everything grows and changes every year. The reason we have seasons on Earth is because the Earth is tilted. Now let's say that this is the Earth. And there's an imaginary line going through the middle of it called the Earth's axis. It's tilted, and it stays tilted as the Earth goes around the sun at 100,000 kilometers an hour. That's 1 billion kilometers every year. Now, not only is the Earth going around the sun, but the Earth is spinning. And when you're on the part of the Earth that's toward the sun, it's daytime. And when you're on the part of the Earth that's away from the sun, it's nighttime. Now, the seasons work in kind of the same way. When the part of the Earth that you're on is tilted toward the sun, it's summertime there. So when it's summertime here at Nye Laboratories, on the other side of the world, it's wintertime in places like South America and Australia.
Hey, Bill, your shoe's untied.
Oh, thanks. Then, when the part of the Earth that we're on is tilted away from the sun, it's wintertime here. And it's summertime on the other side of the world. Isn't that wild? All because the Earth's axis is tilted. That's the reason for the seasons. Why are the North and South Poles the coldest places on the Earth? Well, please consider the following. Let's say that this heat lamp is like the sun, because it's hot. And let's say that this globe is like the Earth, because it looks like the Earth. Anyway, we've mounted thermometers on the Earth like this. See? Now, the one at the equator is just about off the scale. And the one at the South Pole is right around the room temperature mark. And the ones in between are somewhere in between. That's because the heat is hitting the one at the equator almost straight on. Whereas at the poles, it's just barely grazing by. And then somewhere in between, well, it's somewhere in between. You see, it's not that the equator is closer to the heat. It's that the heat is hitting it more straight on. See, if the Earth were sitting like this, then this thermometer would be the hottest, and this one would be the coldest. Anyway, that's why the very warmest places on the Earth are right around the equator, tropical rainforests and jungles. And the very coldest places are at the poles, because they're the ones that the energy from the heat lamp just barely grazes by. I mean the energy from the sun. Well, anyway, thank you for joining me.
Do you notice, though, that the axis about which the Earth turns is not straight up and down. It's tilted to one side at an angle of 23.5 degrees from the perpendicular. This has a lot to do with why we have different seasons, as we shall see.
Let's say that this plastic globe of science is like the Earth, and we have two solar panels mounted on it. Now, solar panels convert light directly into electricity. So right now, these two panels are making enough electricity to run these two little motors. Now, right now, both motors are going about the same speed. Now notice that we have one panel in the northern half of the Earth, the northern hemisphere, and one panel in the southern half of the Earth, the southern hemisphere. They're both receiving about the same amount of light. But let's say it's summer here at Nye Laboratories in the northern half of the Earth, the northern hemisphere. That means that the Earth would be tipped toward the sun about like... Now look. The motor in the southern hemisphere is just barely moving, while the motor in the northern hemisphere is spinning like crazy. Now let's say it's 6 months later, and the Earth has gone around the sun so that its axis is tipped this way. Now look, it's reversed. The one in the south is going wild, and the one in the north is slowed way down. See, what that means is that this panel in the southern hemisphere is receiving more light, more energy from the sun than the one in the northern hemisphere. It's just like the Earth's seasons, right here with the solar panel plastic globe of science.
Using a flashlight, you can see for yourself that direct rays are concentrated on a smaller area than slanted rays. This is why direct rays produce more heat.
So that kind of answers it, really. I mean, that is it, is that the fact that we are tipped towards the sun and away from the sun, the tilt. Earth's axis isn't perfectly straight up and down. Earth is tilted 23.5 degrees in one direction. So when up here in Platteville, when we are tipped towards the sun's rays hit us more directly. And then down here, the sun's rays hit it more not indirectly. So it's winter time down here, and it's summertime up there. 6 months later, as we go around to the other side of the sun, we're tipped the other way. So now it's summertime because they're being hit directly down here, and it's winter time up north. So in the northern hemisphere, it's always opposite what it is in the southern hemisphere. If it's winter up north where we are in Wisconsin, it will be summer in the southern hemisphere, and vice versa. If it's summer up here, then it's winter. And similarly with spring and fall, right? If it's right now it's the fall, so that means it's going to be the spring down in the southern hemisphere. So I hope that clears things up for you as to why we have what we do. And there'll be some experiments that we do with solar panels, just like Bill and I did too, so you can actually see the difference between light hitting it head on versus at a pretty steep angle, and how that affects how much energy is being absorbed.